So let's begin with 3.6, rational functions. All right, so a rational function is in the form of the function r of x with p of x over q of x, where p of x and q of x are polynomials. Okay, so think of polynomials, binomials, trinomials, those kinds of things. And as long as q of x does not equal 0. That makes sense. We can't have 0 in the denominator. All right, so let's take a look at a simple rational function. First example, we're going to sketch f of x equals 1 over x. All right? So what is the domain of this function? Well, when we check the domain, the only restriction here we have is that x cannot be 0. So we know that our domain is everything but 0. So we'll just take 0 out of our domain. All right, so let's go ahead and find out these values. So maybe you could pause the video and take the time to fill out these tables yourself. All right, so filling them out, well, plugging that in for x, we're going to get negative a fourth. Then we'll get negative half, negative 1. Now when we plug it in over here, that's going to be 1 over a negative half, which means we're going to end up taking the reciprocal there, so it'll be negative 2. Same thing will happen with the 1/4. That'll be negative 4. For 0, oh, we can't have that. That's undefined. And then, same again with the fractions. It's going to be the reciprocal, except it's going to be a positive 4. Then a 2, 1, half, and a fourth. All right, so we're going to go ahead and sketch this in. So the only thing, though, is that we have this restriction that x cannot be 0. So no value here. We cannot have an x value here. And this is actually going to be called the vertical asymptote. All right, so x cannot be 0. So we have a vertical asymptote at x equals 0. It's a line x equals 0. Okay. And when we're talking about asymptotes, they are actually lines. So when you write them, they need to be the equation of a line. So x equals 0 or y equals and whatnot. Let's go ahead and plot these points. Let's see. Negative 4 1/4, so negative 4 1/4. Negative 4 4th. Negative 2 1/2. Negative 1 negative 1. Half, negative 2. So negative half, negative 2. Oh, I just realized I was plotting those on the wrong side. Back up here. Good thing I got this handy dandy whiteout. It's supposed to be negatives all the way. So negative 4 1/4. There we go. And because my paper is so squished, I'm not going to write in the coordinate points at this time. If you're asked to write in the coordinate points, you should be writing in the coordinate points. Okay, so negative 2 1/2. Negative 1 1. Negative 4th, negative 4. All right, there we go. Oops, missing some of these guys. So one thing I do want to mention is when you graph these in, the ends should not look like they're starting to shoot back. They should be slowly approaching the smaller and smaller values. Okay, so be careful when you're graphing. Make sure it looks like it should be approaching this asymptote. And then graphing in the top ones. Let's see, so we got 1 1, half 2, half 2, 4th 4, 2 1/2, 4 4th. All right. And there we go. And it looks like it's slowly approaching, but it's not going to hit. There we go. All right, so there we go. We have our simple rational function. Very, very simple. It's just 1 over x. Nothing fancy. So we're going to describe the end behavior and the behavior near the vertical asymptotes using math symbols. So this is our vertical asymptote. We only have one. Let me bring my camera up. All right, so let's go ahead. So we have a few different options here for what we're going to be describing. And A is going to be our asymptote. So this is read as x approaches A from the left. So our asymptote is going to be 0. So let's do this. As x approaches 0 from the left, what does that mean? So remember, the negative means from the left. So as we're coming in from the left, following and tracing our graph, what happens to the y values as it approaches 0? The y values start shooting on down towards negative infinity. So f of x approaches negative infinity. as my x values approach 0 from the left. So what happens as our x values approach 0 from the right? So we're going this direction. So we're approaching 0 from the right, trailing our graph. What happens to our y values? They're starting to get bigger and bigger. They go from 1 to 2 to 3 to 4 to 5 to 6 and on and on and on, as x slowly gets smaller and smaller and approaches 0. So f of x, as we approach from the right, heads towards positive infinity. All right, 2 more to go. So as x approaches negative infinity. So as x approaches negative infinity, what happens with my function? Well, as x approaches negative infinity, it's getting closer and closer and closer to 0. We get closer to 0, but we're not actually touching 0. Okay, so f of x approaches 0. And then, as x approaches positive infinity, f of x, where is f of x? Well, let's see. As x approaches positive infinity and gets bigger and bigger this way, the y values get closer and closer to 0 as well. All right, so that is how we describe the end behavior near the vertical asymptotes using math symbols. All right. So here we go. We got a lot of information on this one page, so this will be a good thing to carefully read through and check. All right, so a linear asymptote. So it's a line that a graph will approach and follow, but it will not cross. So a way you can think about it is like a brick wall. You can walk alongside a brick wall and get close to it, but you don't actually cross through the brick wall. Though there are times when our graph will cross the asymptote, and we can go over those in a sec. So, vertical asymptotes. This is a special case. Our graph will never touch or cross these ones. Vertical asymptotes. Okay, those are the ones that do this. So it's a line, x equals a. Remember, be careful, it's a line. So when you're telling me what a vertical asymptote is, please write it as the equation of a line. And it's a vertical asymptote is if y is approaching positive or negative infinity as x approaches a from the left or right. So just as we saw here, as x was approaching the value of 0, my y values shot off into positive and negative infinity. Horizontal asymptotes. Okay, our graph may touch or cross them. Okay, and we write it as a line y equals b. And it's a horizontal asymptote if our y values approach b as x approaches positive or negative infinity, which is actually what we had here at 0. Our y values are approaching 0 as our x values slowly get positive and negative infinity. And then we have this other option, the slant or oblique asymptote, which also may touch or cross. So this is actually going to be the line with a slope. Okay, this is horizontal asymptotes have a slope of 0. Slant asymptotes have a slope of any other number. And it's a slant asymptote if y is approaching a line with the value mx plus b as x approaches positive or negative infinity. And we'll go more into slant asymptotes in a bit. And notice we indicate vertical asymptotes with VA, capital VA, horizontal asymptotes with capital HA, and slant asymptotes with capital SA. All right, so vertical asymptotes, how do we find them? Well, we factor and reduce our bottom. We factor and reduce. And then we set the bottom equal to 0 to solve for x, okay? So those are the values that we take out of our domain. So just like when you're finding the domain of a function, that's kind of what we're going to do for finding the vertical asymptotes. For horizontal asymptotes, you could do long division. That's one way. Or the other way that we tend to do now is we look at the degree and we compare the degree of the top. So if we look at this example, we'd be comparing the 2 degrees here and here. And we'll go into that in a second. So for a cross-touch point, what you do is whatever the horizontal asymptote is that you found, you just set that equal to your function and see if you come up with a value. So we're going to get into those examples now. First off, state the domain. All right, so take a second to see if you can find the domain. Well, remember to find the domain, we're going to go ahead and factor. Let me go ahead and draw this line through. So I want to find the values that would make this undefined. So factoring this, that's going to be x minus 1 equal to 0. So we know x equal to 1, x equal to 1. All right, so my domain, every number works except for 1. So the domain of R is going to be negative infinity to 1, 1 to infinity. And there is my domain. All right, next, find the vertical and horizontal asymptotes. So for vertical asymptote, well, those are the values that we just took out. This right here is the vertical asymptote, x equal to 1. We get the vertical asymptotes from the denominator, and it's sort of part of when we're finding our domain, which is really nice. So let's see, horizontal asymptotes. What we're going to do is compare the degree of the top of our rational function and the bottom. So the degree of the top function, or the top, polynomial, which we call p of x, is 0. And the degree of the bottom polynomial, what's the degree of the bottom polynomial? That's 2. So how did I know that the degree of the top one was 0? Well, there's no x value, so you could imagine it as if there's an x to the 0 hanging out by that 1. Okay, so the degree of the top one is smaller than the degree of the bottom one. So let's see which option are we looking at? The top one. The degree of our top is smaller than the degree of the bottom, so that means our horizontal asymptote is y equals 0. All right, and please remember to label HA and then your equation and box that. All right, let's see the next one. Finding our domain. Well, let's go ahead and take the bottom. That's going to be where our restriction is. We know that can't equal to 0. Oh, that should have been can't equals. Okay. So x minus 2, x plus 1 can't equal 0. So x cannot equal 2 and x cannot equal negative 1. So in our domain, 2 and negative 1 must be taken out. We can't have those. So the domain of y is going to be negative infinity, but we take out negative 1. We continue till 2, but we take out 2. And then we continue on from 2. All right. So vertical asymptotes, once again, they're rather simple as long as you've sort of found the domain. So x equals 2 and x equals 1. The two equations for our vertical asymptotes. All right, so for horizontal asymptotes, once again, we're going to compare the degrees. So the degree of the top one, p of x, is going to be 2. And the degree of the bottom one, q of x, is going to be 2 as well. Well, they're the same, so when does that happen? So the degree of p of x, if it's equal to the degree of q of x, then our horizontal asymptote is y equals a over b, the fraction of the leading coefficients. So what are the leading coefficients? 1 and 1. So 1 divided by 1 is going to be 1. So horizontal asymptote is going to be y equals 1. All right, there we go, not too bad. So if our top polynomial had a bigger degree of q of x, then we don't have a horizontal asymptote. Okay? If it's bigger, we actually have what is called a slant or an oblique asymptote. Okay, but we'll check into that in a sec. So here we go next, finding the intercepts. Okay, so same idea. Intercepts, they really don't change much. If you're trying to find the x-intercept, you set y to 0, solve for x. If you're trying to find the y-intercept, set x to 0 and solve for y. So let's go ahead and do that. So for x-intercept, we're going to set y to 0 and solve. So y is r of x. Interesting. Okay, we have two fractions equal to each other. I'll put the 0 over 1. So we can cross multiply, which means that's going to be 1 times negative 1, so negative 1, equals 0 times this polynomial is just going to be 0. Oh gosh, my variable's gone. Well, when your variable disappears, check the statement we have. So my statement is saying that negative 1 equals 0. Is this true? No, this is not true. So we're not going to have a solution. If, however, you had solved this and we had like negative 1 equals negative 1, that's a true statement. So we would have infinitely many solutions if this is the case. But we don't have this case. Instead, we have the false statement, 0 equals negative 1, which is not true. So there are no x-intercepts, so none. And please make sure to indicate if you have no x-intercepts by using the word none. All right, y-intercepts. We're going to set x to 0. So y equals negative 1 over, well, that's going to be 0 squared minus 2 times 0 plus 1, which will be y equals negative 1 over 1. So y equals negative 1. Aha, we do have a y-intercept. Negative 1. Awesome. Okay, take a sec and try see if you can find the x and y intercepts for b. All right, so hopefully you went ahead and gave this a shot. I'm going to set these up real quick. All right, x-intercept, set y to 0. Okay, same thing, let's cross multiply. So then we're left with 0 equals x squared minus 2x plus 1. Ooh, we can solve that. 0 equals x minus 2. Ooh, no, x minus 1 minus 1. So we have two solutions, which actually end up being the same number. So x equals 1. So one x-intercept at 1, 0. Now the y-intercept. So setting y to 0, we get, x to 0. Setting x to 0, we have 0 squared. Ooh, lots of zeros here. All over 0 squared minus 0 minus 2. Y equals 0, 0 plus 1. 0, 0 minus 2. So y equals negative half. So there's my y-intercept, negative half. All right. Not too bad. Intercepts tend to stay the same idea. All right, so graphing. Here we go. So the steps for graphing, we got 5 steps. First, you're going to factor the so you're going to factor the whole thing, state the domain, and simplify if you can. Then you're going to find any asymptotes, so you're going to check for the vertical and horizontal. If you don't have a horizontal, you possibly might have a slanted asymptote. Okay, so you wouldn't have both a slanted and a horizontal asymptote for these. Okay, if you have a horizontal or a slanted asymptote, you're going to check for a cross touch point. I'll show you how to do that. Then find the intercepts, and finally, if we need any additional points, we can use the table of values and plot them. All right, so let's start off. Let's factor and state the domain. So let's do step 1. So r of x is going to equal 1 over, let's see, factoring the bottom. We get that, which means x cannot equal 1. So for my domain of my graph, we can use every number except for 1. And I'll box that so my work can be seen clearly. Awesome. Second step, let's see if we have any asymptotes. So for vertical asymptotes, well, we know x cannot equal 1. That came from our denominator. So we have the vertical asymptote, x equal 1. How about any horizontal asymptotes? Well, let's compare the top and the bottom. The top is smaller than the bottom in terms of degree. So that means we have a horizontal asymptote of y equals 0 because our top degree was smaller than our bottom degree. Not too bad. All right, let's see. Next step. 3 cross touch points. So for a cross touch point, what you're going to do is you're going to set your horizontal asymptote equal to your function and solve. Okay, so let's do that. Horizontal asymptote is 0, and our function is -1 over x squared minus 2x plus 1. So let's go ahead and solve that. Cross multiply. -1 equals 0. Oh, that's not a true statement. So no cross touch point. And I just use the shortcut C/T for cross touch point. All right, let's see. Last, intercepts. So for my x-intercept, x-intercept, you're going to set y to 0. Interesting, we just did this right up here. And we find out that -1 equals 0, so there are no x-intercepts either. So we're going to go ahead and write none. And lastly, let's do y-intercept. Set the x's to 0. So r of 0 is going to equal -1 all over 0 squared minus 2 times 0 plus 1. That's all going to go to -1. So y-intercept 0, -1. Awesome. So we have all the information we need at this moment. In the end, we'll see if we actually need to plot some additional points. Maybe we do, maybe we don't. Okay, let's see. First, let's do the asymptotes. So at x equals 1, that's 1. We'll use the dotted line for asymptotes. And please go ahead and label your asymptotes with the equation of the line. And please remember your arrowheads. Right, horizontal asymptote is at 0. So since you can't really see it if I went along this line as well, sometimes I will jet it out on the side. Okay, and then write the equation, y equals 0. Let's see, x-intercepts, we don't have any. Y-intercepts, we do have 1. 0, -1. All right. So what our vertical asymptotes do is they split our graph into sections. So we have 2 sections. And from there, we're going to decide how to graph. So hopefully this is a bit of a review. So when we look at our dot, a point we have, there are options. We look at the right side of the dot and the left side of the dot.